The general idea of the universe, that the whole world knows, was formed in the 17th century by Isaac Newton. I believe that the universe is a big machine that operates according to specific laws. If we know these laws, I can predict the universe in the future, based on past and present information. Newton actually started making laws that describe everything in the universe, starting with the motion of matters, even the laws of gravity. Until a group of scientists such as Einstein, Niels Bohr, Max Planck, and Schrödinger came and stated that the universe has no specific order. The things we are used to seeing are real. They are not real. There is no such thing as past, present, and future. The past can affect the present can affect the future, and the future itself can change the past. This is the universe from the perspective of modern physics and quantum mechanics. After the invention of the lamp in 1879, this is thanks to Thomas Edison, as he was the one who invented it and not someone else. All of Europe was happy that their lives would change, but they did not know that it was the beginning of the curse and that their joy would not be complete. Many questions were hiding in the dark, and when the city lit up, those questions began to appear. The idea of making an Edison lamp is a wire that passes an electric current that heats it up and lights that wire. It was a very great idea, but scientists overlooked the positives and started asking questions. Why, when the wire heated up, the lamp lights up? Why is the color of the light emitted by the wire different when the temperature is raised? At first, the color is red, and when the temperature is raised, the color changes to yellow and then turns to white. Why, the more and more you heat the wire, its color stays white and does not change to another color? And why? Those three questions no one knew the answer to. And whenever a person almost found an answer to a question, he would get a Nobel Prize. Scientists were aware that no one would be able to answer these questions unless they knew what matter is made of. Only then will they find an explanation for it. At the time, it was widely believed that matter consisted of small, round units resembling billiard balls. They cannot be divided and are neutral in electrical charges. That is, they are neither positive nor negative. These units are called atoms. Until a scientist came in 1897 to discover that the atom contains negatively charged balls. These little balls are called electrons. He stated that since the atom contains small balls of negative charge and the atom is electrically neutral, then the rest of the atom is positively charged. He stated that corn is like a watermelon. The black seed is the negative electron, and the watermelon is the positive charge. Then he won the Nobel Prize. 10 years later, another scientist named Rutherford came and had to make sure of this. So he brought a slice of gold and then directed it with alpha rays. It was found that the atom is similar to a watermelon, and most of it is positively charged, and the positive alpha rays that went to the atom bounced back again. But he noticed that most of the alpha rays passed through the gold chip, and a very small part is reflected. He claimed that Thomson does not understand anything, and he is the one who has an explanation. He stated, since most of the rays passed through the slide, so most of the atom is empty space. The atom is similar to the solar system, with a small positively charged nucleus in the middle, and this is what reflected the small part of the alpha rays. Electrons discovered by Thomson revolve around it, which have a negative charge. He also received a Nobel Prize. In this period, a great scientist appeared who proposed a proposal that completely changed the future of physics. It's Max Planck. He did not object to the fact that matter is made up of small pieces called atoms. He did not try to prove it himself. He worked on energy. He stated that energy also consists of small parts and called it quantum. The scientific community wonders how it claims that energy is made up of parts. What a silly theory! Instead of receiving a Nobel Prize, the new physics was called quantum physics, or quantum mechanics. And this suggestion was very strange at the time, as you draw someone's bicycle on the wall and tell them that they can drive it. And you want people to believe that. How can energy be broken down into parts? And is energy a physical thing? It was unbelievable. And it was then that the scientist Niels Bohr had heard about Max Planck's theory and thought that he would be able to find the answer to the questions of Edison's lamp. People marveled as physics takes an unconventional curve. He stated that Rutherford's interpretation is correct, for the atom is similar to the solar system, the nucleus is positive, and the negative electrons revolve around it. He stated that electrons have specific orbits in which they revolve. When the electron gains energy, it leaves its orbit and jumps to a higher orbit, then rotates with it for a while, then returns to its original orbit, and during its return to its orbit, emits light. If the wire of Edison's lamp, when heated, the electrons jumped to higher orbits, then orbited for a while, then returned again to their orbits and released the energy they gained in the form of light. So the wire emitted light. If I heat the wire to a lower temperature, that means I am supplying the electron with just enough energy to make it jump into a higher orbit. This means that when the electron returns to its original orbit, it will emit weak light as a result of it taking a small amount of energy. And it is red. If you heat the wire more, then it will keep the electron from its orbit to two higher orbitals, and when it returns to the original orbit, it will emit more energy light. And it is yellow. If you heat the wire to a higher temperature, the electron will lock into higher orbits, and when it returns to its original orbit, it will emit light with higher energy. And it is white. This is the explanation for the change in the color of the light in the wire. Third, the electron must adhere to a certain orbit, either spinning in its original orbit or jumping to a higher orbit, but it will never be between them. As Max Planck stated that light is made up of small parts called quantums, each of these orbits needs electrons to acquire a certain number of quantums in order to be able to jump to it. If the electron gains less quantums, it will not move from its place, and if it gains more quantums than the orbit requires, it will not move from its place. But how if he gained more quantums he wouldn't jump? He would have gained even higher energy. It won't happen. An electron needs a certain number. So when the wire was getting hotter to the max, it only radiated white light. The community was fascinated by this interpretation, and he and Max Planck were awarded the Nobel Prize. But if you think about the content of that interpretation, you will find that it is strange. If I am standing at that point, and I want to move to that point, I must cross the distance between them. The electron does not. An electron stands in its orbit and gets quantums that enable it to move to a higher orbit. It disappears from orbit and appears in a new orbit, without cutting the distance between the two orbits. But how? Nobody knows. Does it go to a parallel universe and then come back? Or does it travel in time? All of these are philosophical interpretations, and no one can find a logical answer. But society was satisfied with this interpretation because it was an answer to many questions. During this period, Einstein was working on the photoelectric theory. He noted that if you have two wires separated from each other, then spotted a light source on them, an electric current will pass between them. This means that the light was able to collide with the electrons in the two wires and release them. This is the idea of the work of solar cells that produce electrical energy using sunlight. Einstein found that the intensity of the light is not the cause, but the color of the light. For example, if I have a blue light that is very weak, it can liberate electrons from the wire, whereas if I had a very strong red light, it would not be able to affect the electrons. Does that make you think of anything? Edison lamp wire. When I raise the temperature to a certain value, the color of the light does not change. So each color of light has a different number of quantums. The electron chooses the quantums it needs. Salute to Einstein for inventing the photoelectric theory and giving him the Nobel Prize. But then Einstein discovered that he had made a terrible mistake in physics. Electrons are very small balls. That is, it is material, or something called a particle. So the thing that hit him must be physical, to be able to move it. The billiard balls will not move unless they are hit by another ball. Thus, Einstein's conclusion means that light is an object with mass, and this is not what was known at the time. Newton in the 17th century believed, as did Einstein, that light were small balls. But after him came a scientist named Hooke and did an experiment that we won't go into details right now. And he discovered that light is not small balls and is not material, and you cannot catch it. And that light is a wave. And all the experiments that came after Hooke's interpretation proved that light is a wave and not a particle. But what is a wave? A wave is a disturbance of matter. For example, if it is a water wave, then it is the disturbance that occurs to the water, not the water itself. If you create a wave with a rope, then the rope guide is the disturbance that occurs in the rope and moves it up and down, not the rope itself. A light wave is the disturbance of light, who is not materialistic, and it has no mass. Wait a moment, what is this? It doesn't make sense. What will move? They stated it was a disturbance. Isn't turbulence only for mass materials? Light has no mass, but this is a disturbance, and all the experiments proved that it is a disorder. Einstein wouldn't explain light as little balls again. We will not go back to the 17th century. Einstein explained, light is neither directed nor particle. Light is directed and particle. Both. This was the first strange explanation in quantum mechanics. At the same time, there was a student named de Broglie who had just obtained his PhD, heard about Einstein's work. He liked it and decided to do his own experiments. Einstein stated that light can be both positive and particle at the same time, and he won a Nobel for that. But since light can repel an electron, then the electron can be both a wave and a particle at the same time. Deserves a Nobel. This explanation is very dangerous if the light can be a wave and a particle. But how does the electron become directed? This interpretation is contrary to reason and logic, because that means that the atom is a wave and matter is a wave. That is, you, me, de Broglie, Einstein, and all people are waves. Just wave strikes, meaning there is nothing real. The fact is not the fact. And despite what de Broglie stated, he got his PhD and the Nobel Prize. But he left behind a very big question. The electron that has mass, how does it become a wave? And if it is a wave, where is its place in this wave? And how does it expand inside it? Until after him came a scientist called Schrödinger. Yes, who has a cat. He is the one who solved the problem, and he created an equation called the wave equation that explains how the electron moves. Excellent! So, where is the electron? Didn't know. So we need to explain the equation in order to be able to imagine it. And he couldn't do that either. This equation only describes its motion. All I want is a Nobel Prize. He has been awarded a Nobel. Another scientist named Heisenberg saw that Schrödinger was disappointed when he couldn't find a rational explanation. He thought that this question should not be asked. And he worked out a famous principle called the uncertainty principle. And he stated that the location and speed of an electron cannot be determined at the same time. That is, either you consider the electron a vector and know how it moves, but don't ask where it is, or that you consider the electron a particle that looks like a small ball, but do not ask how it moves. They felt that Heisenberg was offering a logical explanation, so they gave him the Nobel. Immediately after him came a scientist named Max Born and set out to solve the dilemma. Although he could not figure out how to locate the electron during its motion, but he was able to know the probability of the presence of the electron in a particular place. For example, if I have a wave, the electron can be found here by 50%, or a 30% chance of him being here. There is a 20% chance that he will be here. Or maybe it's not here at all. Max Born took the Schrödinger equation and modified it, and he created a new equation by which you can find out the probability of the existence of the electron. Like any other world that has gone through this, he got a Nobel. But it means that when you exist from Bohr's point of view, I became present and non-existent at the same time from de Broglie's point of view. From Max Born's point of view, your existence becomes probability. And if you wonder at these explanations, because this is not the fact as you see it, you must know that the phone you are using works with these theories, LED lights and electron microscopy, and magnetic resonance imaging. And you should know that the upcoming episodes will become even stranger than this episode. And don't forget to like, comment, share, follow us on Facebook, or tap notification button to know when the upcoming episodes come out.